All right, so we're given this function y, and we want to find dy dx. We have a hyperbolic inverse here. Just a quick fact here. Recall that the derivative of cosh inverse of x is equal to 1 over the square root of x squared minus 1. So let's apply this fact to our problem. We want to find dy dx, so we'll take the derivative of that with respect to x. So the derivative of y with respect to x is dy dx. Now, the derivative of cosh inverse is this definition. It is a ratio where 1 is always the numerator, square root something squared minus 1. That's just the formula. What goes in here? X. What is x? X is the original input. What is the input here? The square root of x. So that's what I copy and paste into there. I clean this up. The square root of x squared is just x. So I've applied the derivative, but there's one thing you have to remember. And this is one thing that the fact here doesn't really emphasize, and that is the chain rule. Okay? So when we take the derivative of this here, that's that there, the derivative of that is that, the derivative of this is that, but I actually almost forgot to multiply by the derivative of this object. You see here, the derivative of x is just 1, which is in the back, which is invisible because it's just 1. But the input is not always x. In this case, the input is the square root of x. So I have to multiply, according to the chain rule, I have to multiply by the derivative of the square root of x. What is the derivative of the square root of x? It's 1/2 x to the negative 1/2. I trust that this is something that we already know. So let me just carry that down here. So that's 1/2. I'll just put 1. I'll put the 2 there. And x to the negative 1/2, I'll drop it to the bottom as a square root. So if I clean this up, our derivative should be 2 square root of x minus 1. This is our derivative. It's pretty clean the way it is, but now they also want us to tell them what values of x are permitted. In other words, the domain. Now they also wanted us to tell them what values of x we can use for our derivative. So let me just hold my phone here by hand. Well, here's one way of doing this. Check this out. So we know that this is the original function. So I took the liberty of typing in that original function into decimals and I called it f. And in line number 2, I typed in f prime, the derivative. So let me zoom out here. All you can see now is the original function, which is here in green. If I click on this here, it activates the derivative, which is this purple. So the domain is all the x's that the purple graph uses. Well, notice that the purple graph, the derivative, it begins at x equals 1, and it moves to the right forever. So let me just hold up my pen like this. You see that? This derivative, there's only activity from 1 and greater. So that tells you that the domain is x greater than 1. So this is like a fast way of doing it. I'm not going to use the word cheat. This is an efficient way of finding the domain, assuming you guys are allowed to use graphing calculators. So for now, I'll just say that the domain would be x greater than 1.